Assalamualaikum and hi everyone. Welcome to Computer Science 1, lecture number 2. Today we are going to look at, still we are in topic number 1, and the second subtopic in topic number 1 is number system and representation. What we mean here is data representation. Okay, our learning outcomes for today is only one, that is you should be able to explain data representation in computer. So what is data representation? It means we are going to look at how data represents the information that we type into computer. How computer represents those data that we type or we process. So as we can see in our view, data is in the form of text or numbers or symbols or maybe an image or audio. So when we type, key in, or when we enter those data in computer, we do not think of how those data is represented in the computer, because immediately we can see the thing that we type in the screen. So now we are going to think how computer represents those data. So for example, when I type M, how does M looks like inside the computer itself? So we must know that in the computer, the computer consists of many tiny devices called transistors, and these transistors exist on electricity. Computer is a digital device which exists on electricity. What it means is that in those small tiny switches, there are only electrical signals. Alright, so anything that we type into the computer is going to be represented in electrical signals or electrical states, on and off. So in our world, human world, the only number system that has two states is we call binary system, because it has digits 1 and 0. Therefore, we use those binary system to represent the electrical states on and off. That is why a binary system is used to represent data in computer. So what is bit? Bit is a short of binary digit, which is 0 or 1. Bit is the smallest unit of data that computer can process. So this definition is very important for you to remember, because this is what you should explain. Okay, so a bit represents an electrical state on and off, where bit 1 represents on and bit 0 represents off. Alright, if we use only bit, we can represent only 2 data, because there are only 2 bits. So we must combine those bits to make it a byte. What is byte? Byte is a combination of 8 bits that are grouped together as a unit. When we say byte, it means 8 bits as a unit. So when we have a byte, when we create a byte, 8 bit as a unit, we will have many combinations or many forms of bytes, because we can create 0000, 0000 as the first byte, and the last byte is 1111, 1111. So all together we will have 2 to the power of 8 numbers of bytes, meaning we are going to have 256 bytes altogether. So now we can use those bytes to represent our data. For example, 0011 0100 can represent the number 4, and 01000 represents a letter E, and many more. We can use bytes to represent our data. Alright, so now we are going to look at the units to represent memory in computer. So we have units for everything. For example, we have units kilogram to represent weight. So now we are going to have units like kilobyte, megabyte, gigabyte, terabyte, and petabyte, and more to represent the memory or the storage capacity in computer. So you have to know how much is 1 kilobyte, how much is 1 megabyte. We always use for example megabyte and gigabyte to represent our storage capacity of our device. For example, for pen drive, alright, maybe you have a pen drive of 16 gigabyte. So what that means, you have to know that. So 1 kilobyte is actually equals to 1024 bytes. It's not just 1000 bytes, okay? Even though the word kilo means 1000, but we are working in binary system. Binary systems means 2 to the power of 10. Our kilo is 2 to the power of 10. So 1 kilobyte is 1024 bytes. And 1 megabyte is 1024 kilobyte. 1 gigabyte is 1024 megabytes. So we will use this to convert. If you are given, for example, 2 gigabyte, how much bytes is that? Alright, so to convert between those units, if we work from small unit to big unit, we have to divide by the units. And then if we work from big unit, from gigabyte to megabyte and so on, we are going to multiply. Okay, so maybe this example will make it clearer. For example, you are given 8 gigabyte to convert to a unit kilobyte. So from gigabyte to convert to megabyte, we have to times 1024, and then further we are going to multiply 1024 to get a kilobyte, right? So we are going to have about 8,388,608 kilobyte. What does that mean? That means that is 8 gigabyte. Alright, so from bigger to smaller unit, you are going to multiply by 1024 and 1024, because we have two steps here. From gigabyte to reach kilobyte, you have to go to megabyte first, and then you have to go to kilobyte. That's why we are going to multiply 2 times. Okay, next example. For example, we have 1200 megabyte. This is a smaller unit going to a bigger unit. So megabyte to gigabyte, you have to divide. Alright, 1200 megabyte divide by 1024. Now we will have 1.17 gigabyte. Alright, so that's all for now. Thank you.